Welcome back again to the class. We're starting recursion. What is recursion? Recursion is a process of using a function or procedure that is defined in terms of itself and also calls itself. In the previous classes, we understood what is function. When we write functions, we write def function, then we write all the codes we want to write, then we are done, then we call the function. It is until the function is called that this task is executed, isn't it? Isn't it? Good. But for recursion, it is kind of different. What does this mean? What I just explained now means the function is defined. When the function is defined, you write your set of code and you now call the function inside the function. And when you are done, you still call the function outside of the function again. Because it is until you call this function that this function is executed. When this function is executed, it keeps calling itself. It keeps calling itself and re-executing. Call itself again, re-execute. Call itself. So the only thing you need to do is to call it once. When you call it once, it calls itself again. And do this task again. Do it again. Repeat, repeat. When does this stop? It does not stop. It only stops at a point where you define it to stop. And that point that you define it to stop is called the terminating point. What do I call it?
Terminating point.
And that is called the base case. What do I call it?
Base case.
The base case. That is the point of what? Of termination. Because if you don't terminate, it keeps calling itself over and over until eternity or until your laptop goes off or whatever. Do you understand? Why the recursive case is this case where you call the function back. Do you understand? Where the function keeps calling itself is called what? The recursive case. It's as simple as this. Okay? Recursive function is a process to solve a problem. Another thing we can use or another method we can use apart from the recursive function is the iteration. Is the what? Iteration. So whatever task you can solve with recursion, you can also solve it with what? With iteration. What does iteration means? Iteration means when you try to use loops to solve a problem over and over again. Is that understood? The one that is commonly used, that is commonly close to us is the for loop, isn't it? When you use for loop to solve a problem, when I write for something in something, then that means this will execute the number of times you have written the for. It starts at a point and ends at a point. Is that understood? So let's solve a problem with iteration. To revise what we know with iteration, then we now solve the same problem with recursion so we can understand what recursion is. Okay? Now let's go back to iteration to solve a problem. Let's take an example of an array. An array of 4, 5, 7, 12. We want to add all these numbers in this array. So let's solve this problem with iteration. Okay? To solve with iteration, we can write for num in range of the what? Of the length of array. Okay? Then I might have declared a sum to be equal to 0. So that when I get here, then I write that sum is equal to what? Sum plus what? Array of num. When I am done, then I print sum out of the loop when I'm done. Okay? Good. If you take a look at this, what happens? We are writing for num in range of length of array. The length of array is 4, isn't it? Range of 4 returns what? 0 to 3. That means the for loop will iterate from num to be equal to what? 0 up to 3, which is how many iterations? 4. Is that understood? It takes the first value, add it to sum. It goes back, take the second value, add it to sum, goes back, add it to sum, and prints the final value of sum, isn't it? So when you run this code, you see your results as what? As 28. And that is all. So let's solve this same problem with what? With recursion. Okay, to solve recursion, you cannot solve recursion without two things. You must identify the base case and what? And the recursive case. If not, you cannot solve. And to understand recursion, it's better to write it in a mathematical term. That is the best way to understand recursion. What do I mean? I have to write that sum is equal to, do you guys understand this mathematics? That you have to write two times, like maybe 2 or 3 times or 4 times. So write it in this mathematical way. That will help you to understand it better. Is that understood? Where this will be you write your base case here and write your recursive case here. Okay? So you have to determine the base case. So if you want to use recursion, how do we use recursion? Our array, the array is equal to 4, 5, 7, 12. To use recursion means that in this case, let me explain this way. By the time I solve 4 or 5 examples, different forms of example, maybe you understand it in a broad shell. What I'm trying to do is I will take this first value, which is 4, then add it to the sum of the rest. Sum of 5, 7, 12. Will it give me the same results of adding them individually? Will it? Yeah. Will it? Yeah. It will give me the same results. So it's like adding the first to the others. So that means that sum is adding the first value, which is array 0. Okay, which is what? Array 0. Then we add it to what? To sum of what? Of the remaining items in the what? In the array. Is that understood? Can you see? Sum. The function has called itself. Sum inside sum. So that's how you can understand recursion. Do you understand? If it's not calling itself, then you know there is a trouble, there is a problem. What is now the base case? Let's try and understand the base case, because one thing students find challenging is how to identify the base case. If I take out the first value, what is the first value? 4. I took it out. Add it to the remaining. By the time I'm recalling it again, then I take the next first value. Isn't it? What will be the first value now in the remaining? 5. Then I add it to the what? To the sum of 7, 12. Is that understood? I come back to take the first value, which is now what? Then I add it to the what? The sum of the remaining. Is that understood? Then I take the first value again, which is now what? And add it to the what? Sum of nothing. So that means that I must stop when I get an empty value. That is how to determine the base case. Is that understood? That means I must stop when I get to the what? To the empty, because there is nothing to add again. I keep taking the first value, adding to the remaining. Take the first value, adding to the remaining. That means when I get to the end, when the array is empty, I should stop solving. So that will define the base case. Is that understood? That will what? Define the what? The base case. So that means in this case, I will say that the base case is when the array is what? Empty. Is that understood? That is the base case. Is that understood? So because I always add, then the sum will be equal to 0 because I was adding. If I make the sum to be 1, then it will affect my results. Is that understood? So the sum should be what? 0 at that point. So because that is the end. Make the sum to be 0. So what now happens? I will tell you. Let me write the code to illustrate, because this is a code. This mathematical expression is a code. Let me write the code. let's see the result. Then I will now explain to you what actually happens in the background. Okay, so let's write the code to do this. Now to write the code for this expression, let's write the recursive function def recursive sum. Then we pass the array as a parameter. Array. Is that understood? I can write sum is equal to 0 where I want to add all the sums, isn't it? Good. Okay. Now the first thing in this mathematical expression, what is the first thing we wrote? The base case is the first thing. So you should not write the recursive case first. Write the base case first. Is that understood? According to this expression. So we follow that logic. Is that understood? Then we write that if the array is empty. How do we know the array is empty? Now, before I go here, let me write an array. Array is equal to this. Is array empty? So let me write if array. If array, it means if the array has values. Print 2. Okay, else print false. What do you think this will print? False. It will print false. Why? Because the array has no values. Is that understood? So let's run this code now. It printed false. If the array has values 1, 2, 3, it must print what? Print 2. Can you see that? So that means that to identify if an array has values or not, you can use your if statement to check the condition or what it will return. Is that understood? So since according to this expression, if the array is empty, it means I want to check if the array does not have a value, isn't it? So you have to write what? If not array. Because if it is if array, it will return true. Is that understood? So if not array, what will it return? False. Is that understood? Because array has value, it returns true. If array does not have value, it returns what? False. So if not array means it returns false. So that means the array has no value. That is if the array is empty. Is that understood? Is that understood? Then we write that what? Return 0. Why am I returning 0? Because I want to end the function. When a function hits a return, it terminates. Base case means the point of termination. Is that understood? So I need to use return so that it does not continue to execute. I need to break out of the function. And the only key way to break out of the function is what? Is return. Is this understood, everyone? Okay, good. So else. That means if the array is not empty. What is the expression? Add the first value to the sum of what? The remaining value, isn't it? What is the first value? Array 0. Okay. You now add it to the sum. And what does the sum? The sum is not addition. The sum is the function. That was why I said function is equal to function. Can you see? So this sum is the function. That means you recall the function. Is that understood? So that implies that I have to recall the function as recursive sum of what? Of the remaining part of the array. And the remaining part of the array is what? From the first element to the last element. Is that understood? From the what? Sorry, from the second, not first. Because 0 index 0 is what? The first element. Index 1 is what? The second element, isn't it? So that means from the second element up to the last element. Is that understood? So this is what we are going to return. Return. I don't even need this sum. I don't need it. I can just return that. Or I write that sum is equal to this. Then when it's done, then I return sum. I think this is fine. This is better. Is that understood? Or you return that function because when it hits this, it will recall the function. It terminates and recall. When it hits it again, it terminates and recall. Do you understand? It keeps recalling until the array is empty. So let's execute. Then let's initialize an array as 4, 5, 7, 12, the same array, and call that function, isn't it? It's going to return something, isn't it? Then I write returned value is equal to recursive sum of what? Of array. We pass the array as what? As a parameter, isn't it? If you take a look at this, when you call this function, you still pass one array as what? As a parameter. Is that understood? Okay, good. Then we do what? Print recursive sum. Sorry, print returned value. So when you run this, then you should have 28. Let's draw the trace table to understand what actually is going on at the background of this code. So the array is equal to 4, 5, 7, and 12. So for the first call, this is the first call where this function is called with what? With the parameter, isn't it? Isn't it? Okay, good. So you call the function with the full array. And what is the full array? 4, 5, 7, and 12. Is that understood? So, okay, let me write that out here. Instead of call 1, so let's call the function. So that is function with 4, 5, 7, 12. Is that understood? So let's see what it will execute. Is the array empty?
No.
So will it return 0?
No.
No. So what does it return? Array 0. Oh, sorry, what does it execute? It executes this, isn't it? So it executes what? Array 0. What's array 0? 4 plus, then we call in the function again, isn't it? The function of what? Of the remaining values in the array, isn't it? What is the main value in the array? That will be array what? Okay, good. That will be function of 5, 7, 12. Is that understood? Then it returns nothing. Nothing is executed yet. Is that understood? Nothing is executed yet. Now, for the second call is when the function is called the second time. Are you all following me? When the function is what? Called the second time. Now, do you know that the function is called the second time at this point, isn't it? Now, the function is now called. So what was the parameter that was passed to the function when it was called?
5, 7.
It was 5, 7, 12. So this was when the function was called the second time. Are you all following me? When it was called, what? So it checked the first line. Is it empty? No. Then when it's not empty, what does it execute? Array 0. What is array 0? 5 plus the function of what? 7 and 12. It returns nothing because it's not going to do the real addition. It's just recalling the function. It's going to add, then call the function. So the addition is not just done. Is that understood? So nothing is done. Now, once it called, now it has now recalled the function. Is that understood? Which is now the third time. So function, the function of what? 7, 12. Is that understood? Now, is the array empty? No. It goes to execute this, isn't it? So what is the first thing it takes? The first value, which is 7 plus. It recalls the function again, isn't it? That will be function of what? Of 12. It still returns nothing. That is now a new call, isn't it? For the new call, it calls function what? Function 12, isn't it? What is the first value in the array? 12 plus function nothing. There's now nothing. It returns nothing. Now it now calls again, isn't it? But it calls with an empty array. So call function nothing. It calls. Is that understood? When it now calls, is the array empty? Yes. What does it return? Zero. It returns 0. Is that understood? So it returns, so the array is empty, it returns 0, and it executes 0, or don't execute, it returns 0. That is all, and 0 is returned. Now, when it now gets to this point, it has been terminated. So what is now actually going to happen? It's going to use a stack. When all this is happening, it was actually keeping all this in a stack. So this is a stack. What is a stack? A stack is when you have an item, if this is the base, like this is a table. Okay, this is a table. Now you added an item to a table. This is item 1. You added another item on item 1, which is now added to item 2. You added another item. You added another item. You added another item. When you are done, you now want to take out the items one by one away. Which one will you take first? The last one is the one. That's why it's called a stack. Is that understood? So a stack is an abstract data type. Now, this is now implemented in a stack by taking the last function out first. Is that understood? Now, what does it do? So it now goes to the stack. What is the last function? 0. Is that understood? Now it now goes back to the last one after 0. What is the last one after 0? Function 12. So function 12. Is that understood? How will it execute function 12? Function 12 means add 12 to when you call to the result of when you call function empty. When you call the empty function, what does it return? I mean, when you call the function with an empty array as a parameter, what does it return? That it becomes 12 plus 0. Now it returns 12. Is that understood? It goes back to the last one, next one, until it's done. Just take out of the stack from the last one to the first one until the stack is empty. Is that understood? Until the stack is empty. Then it now goes back to the last thing. How does the stack works? You take it out, then you go to the last one until the stack is empty. Do you understand? Is stack empty? No. What is the last thing? That was the function when you pass 7 and what? 12 as the parameter. Is that understood? Now, function when you pass 7 and 12 as a parameter. So when you pass 7 and 12, what will it execute? It executes 7 plus what was returned when you call what? 12. Do you understand? When you call the function, when you pass 12 as a parameter, and what was returned? 12. It becomes what? 19. Is that understood? Now it goes back to the next value in the stack. Is that understood? Which is what? Function 5, 7, 12. What will it execute? 5 plus when you call the function and you pass 7 and 12 as the parameter. So when you pass 7 and 12 as the parameter, what does it return? 19. It becomes 5 plus 19. And that gives what? 24. Is that understood? Is that the end of the stack? No. It now goes to the next value in the stack. Is that understood? Which is what? Function of 4, 5, 7, 12. What will it execute? It executes 4 plus when you call the function and pass 5, 7, and 12 as a parameter. And what was returned in that time? 24. And that will be what? 28. Is the stack empty now? Yes, the stack is empty. And your final answer is 28. That was the reason this returned a 28 when you ran it. Is that understood? That was the reason it returned a 28 when you ran the code. So when you actually ran the code, you did not see all this. You only saw the 28. Do you understand? So why? Because all this is implemented in the stack, and the stack is an abstract data type. The reason why I returned 0 as my base case and not another value is because at the end, I am adding the first value where I am adding. I am not multiplying. I'm adding. So what this does is when it gets to the base, it is adding, look at this execute. You are adding 12 plus when you call the function with an empty array. So the value returned by this will be added to 12.
Yeah.
So if I have returned a 1 year, 1 will have been added. If I make it -1, -1 will be added to 12. And when you add -1 to 12, it becomes what? 11. It will affect this result and become 27 on the long run. And that's what you must understand. Do you understand? So if I was not adding, maybe I was multiplying, I cannot make this to be returned 0. Do you know? Because if I make it to return 0 and I multiply, my final answer will be what? Will be 0. So it depends on what you are working on. Your return may not be 0. It is 0 here because of the type of the question I'm working on. If I'm working on something else, it will not be 0. It will be something else. So it depends on what you are working on. In the next class, we will solve more questions with recursive functions, more different questions, so you can understand different ways of how you can identify your base case with different levels of difficulty and different things you have to return in your base case. So we